Good day, students. In this video I will show some solution to selected questions from chapter 12 progressions 12.2 geometric progressions. Write each of the following recurring decimal as a fraction. Okay, so you have decimals here, and they want you to convert the decimal to a fraction. Okay, so that's the beauty of geometric progressions. You can convert a recurring decimal, a decimal that doesn't end, to a fraction by using the formula that we have learned in this chapter. Okay, so I'll do the first one. A 0.888, and it continues. So this recurring decimal, I can change it to a geometric progression. How? This is actually a 0.8 plus 0.08 plus 0.008 and so on. So when you add all this, you will get this number. And this one, I will assume this as a T1 or A, first term. Okay, so this is your A, and I can find the R. R is T2 over T1, and I'll assume this as T2, the second term. So R will be 0.08 over 0.8. Use your calculator and you'll get this as 0.1. Now I have my R, I have my A. I can find the sum of the terms to infinity, that is S infinity. S infinity is actually refers to the total sum of this, the recurring decimal that was given in the question. So the formula for sum to the infinity is A over 1 minus R, and our A is 0.8, 1 minus R. R is 0.1, so you get 0.8 over 0.9, and change to fraction, you get 8 over 9. So see, now we have a fraction instead of a recurring decimal. You can test that out whether this fraction will produce this recurring decimal. So I'll use a calculator again. So it's 8 over 9. 8 divided by 9, and yes, can you see, it's the same recurring decimal. So as I said earlier, we can use geometric progression to convert recurring decimal to a fraction. Okay, I'll do the next one, B. 0.42, but here we have a dot on 4 and on top of 2. So 0.42, and there is a dot. What does this dot means? This means 0.42, 42, 42, and so on. That means it repeats by repeating the number where we have the dots on top of it. So it's 42 means 42, 42. So the 42 repeats. And I can rewrite this as an addition as 0.42 plus 0.0042 plus 0.000042 plus and so on. Okay, so the same way I did the first one. Now for this recurring decimal, this is your T1, which is A. Okay, I can find the R. R is T2 over T1. What is your T2? This is your T2. Zero 0.0042 over 0.42. You will get 0.001. Okay, 0.001. Let me do that in a calculator just to confirm. Yeah. Oops, sorry. No. Yep. I have more 1 0 0.01 okay. Okay, 0.01, that's your R. So I'll continue this side, continue my B here. Now I want to change this to a fraction, the recurring decimal. So I can, to change to fraction, you need to find the S infinity or sum to the infinity. So S infinity equals to A over 1 minus R. And what is your A? From here, your A is 0.42 minus R, 1 per over 1 minus R. R is 0.01. So you get 0.42 over 0.99, and change to fraction, you get 42 over 99. Okay, so I can test that out, use my calculator. 42 divided by 99. Yeah. Okay, so moving on to the next question. C, use the same color of pen. C, 0.06, and you have two dots on the top, that means 0.060606 and so on. So this is 0.06 plus 0.0006 plus and so on. So what will be your T1? This will be your T1, and this will be your T2. And find the R. R equals to T2 over T1. That will be 0.0006 over 0.06. Okay, so you divide these two. You can use the calculator again. And get 0.01. So I can find the fraction. So to find the fraction, I need to find the S infinity. A over 1 minus R. A is 0.06, 1 minus R 0.01. This will come 0.06 over 0.99, 6 over 99. You can see that. Yep. So simplify this, I get 2 over 33. Okay, I can test this out whether I can get the recurring decimal back. 2 divided by 33. Yep, that's the recurring decimal. Okay. Moving on, D. I don't have a space. I'll use another paper. Okay, in D, it's a recurring decimal. 3.27, but remember the dots are only on top of 2 and 7, not 3. So it will be 3.272727 and so on. So I'll do this, change this into an addition. I'll get 3 plus 0.27 plus 0.0027 and so on. Now, which one is your A? Your A is not 3, because if you take your A as 3 and your 0.27 as T2, you won't get a geometric progression. This will be your A, your T1. Okay, and this will be your T2. Only taking this as T1, you'll get a geometric progression. We leave 3 apart first. So I know my T1. I need to find my R. R is T2 over T1. So what is your T2? 0.0027 over 0.27. I'll get 0.01. Now to find the fraction, find s infinity, a over 1 minus r. What is your a? 0.27. And what is your r? 1 minus 0.01. You'll get this as 0.27 over 0.99. So simplify 27 over 99. Simplify some more. You can divide by 9. You get 3 over 11. But remember, we have a 3 in the front, so 3.27 is actually 3 plus 3 over 11. So you get 3 over 11. So change it to improper fraction, you will get 36 over 11. Okay, that will be the answer. If you want to check that out, you can use the calculator. 36 divided by 11. Yep, 3.2727, as I said before. Okay, moving on to the next question. It is given that the price of product increases by 10% each year. If the price of the product in the first year is 600 ringgit Malaysia, calculate its price to the nearest ringgit in the 10th year. Okay, so I'll do this. I'll just rearrange the paper. Okay, so the price of the product increases by 10% each year. Okay, so increases 10%. That means that's your common ratio. Your common ratio is 10%. Change it to decimal or fraction, doesn't matter. 10 over 100. So this becomes 1 over 10 or 0.1. Okay, and your a, your first term is given is 600. A is 600. Now they want you to find the price nearest in the 10th year. That means your 10th term, T10. So the formula is AR to the power of n minus 1. A is 600, R is 0.1, n minus 1 is 10 minus 1, 9. So use your calculator, I can get the answer. Sorry, yeah, the R is the product, the price of the product increases. Okay, so the increases, I made a mistake here. So it's not 10%, it's 110%. 110. Yep. So you get 11. So it's not 0.1, it's 1.1. Okay, so it's not 0.1, it's 1.1. So I'll do it again using the calculator. So the answer will be, okay, they want you to find it nearest ringgit, so the answer will be RM1415. That will be the answer. Okay, so repeat again, it's product increases by 10%. That means it increases 10%. It's 110% from the previous year. 110, not 10%. So we convert that to a decimal, you get 1.1, and then use the formula to find T10. Okay, moving on to the next question. Hope you can see. Yes. The diagram shows a part of a series of squares with ABCD as the first square. We have ABCD, the biggest square, as the first square. AEFG is the second square. AEFG, the second square. AHIJ, the third square. Okay, AHIJ, and so on. Each square is drawn in such a way that the length of each side is half that of the previous square. That means it's 12, then becomes 6, becomes 3, and so on. So it becomes half and half and half. Find the area of the sixth square in the series. This is the first square, ABCD. They want you to find the area of the sixth square in the series. So how to find that? Okay, I'll find the area of the first square. First square ABCD is 12 times 12. It's 12 times 12, followed by the second square is 6 times 6. The third square will be 3 times 3. That you'll get 144, 36, 9, and so on. So your A is 144, your R is 36 over 144. Use calculator. So you get 1 over 4, or in decimals 0.25. Now you need to find the area of the sixth square. That will be T6. A R to the power of n minus 1. What is your A? 144. Your R is 0.25. N is 6. 6 minus 1 is 5. Use your calculator to solve this. Get 9 over 64. Okay, the area will be cm square, so yeah, cm square. That's the area of the sixth square. Question B, the total area of all the squares that can be drawn in this manner. Total area means it's S infinity. Asking you to find S infinity. I'll use a different color of pen. So S infinity total area is A over 1 minus R. What is your A? It's 144. 1 minus R is 1 over 4. You get 144 over 3 over 4. Simplify this. 144 times 4 over 3. 4 goes up. I'll do that with the calculator. Okay, I'll get 192 cm square. Okay, the area, so it's a cm square. So this will be the answer for B. That's all for this video. See you again in the next one. Bye.